Hello, welcome to Math 8, Unit 3B, Lesson 2. Today's objective is scholars will be able to understand correlation and create lines of best fit to represent data. So, first, what is correlation? You should have your notes out and be filling these in. So, correlation is a pattern or relationship between two pieces of data. Remember, we're looking at bivariate data, two pieces of data. Correlation does not mean causation. So just because two things have a correlation does not mean that one causes the other. They could both be caused by another outside factor. So let's look at some different types of correlation. So there is a positive linear correlation. So this is a positive linear correlation. So the points lie close to a line. So you see that you sort of see a line going up here, right? And as x increases, y also increases. You see how they sort of form a line. Then you have a negative linear relationship. In this case, the points lie close to a line, but as x increases, y decreases. So you notice this is a line that's going down like this. Remember, everything goes from left to right. So this is a positive slope. This is a negative slope. It is a negative correlation. Then there is a non-linear correlation. Sometimes you can see a pattern, but it might be some sort of curve. So this one, you can see that it sort of has a pattern, but it's more of a curve than a line. That happens sometimes. It's a non-linear relationship. Finally, sometimes there just isn't a relationship. There's nothing that you can say. There is no pattern. If I look at these, if I know what x is, it doesn't tell me anything about what y is. Okay? So sometimes there is no pattern. So again, positive correlation, negative correlation, nonlinear, and no relationship. So the next thing we're talking about is what is a line of best fit. You'll notice that we talked about things having a positive or negative linear correlation. So a line of best fit is a line that represents the data and can be used to make estimates and approximations of expected data points. So you see here, this is a scatter plot that has a negative correlation. And you'll see that they have a line here. Notice that the line follows the pattern. So it follows the pattern. And about half the points are above it and half of them are below it. So half points above, half below. That's what we're looking for. And they gave us the equation for this. So we have our y-intercept, and we have our slope. Notice the slope is negative. Okay? So, how can we use correlation? So let's look at this data. So when we're trying to do a line of best fit, the easiest way to do it is, hold on, so let me move this over just a little bit to make it easier. So, if we can make an oval around all of our data, so we'll draw an oval around it, then we want our line to sort of go through the center of the oval. In this case, it looks like the line would go like right there. Again, it should be split about half above and half below, and it should follow it. And then we can write an equation for this line. And we're going to write the equation by simply finding our b and our m. So we know y equals mx plus b. In this case, our b is right here. It's a little above 0, so I'm going to say our b is maybe 0.25. I know that my line has to have a positive slope. So, and remember, at this point, we're looking at our line. So I see right here, it sort of hits at 2, 2. So I've got the points 2, 2. And another point where it hits pretty close is, right here. And that's the point 6, 5. Remember, to find our slope is change in y over change in, so y2 minus y1 over x2 minus x1. So in this case, m equals 5 minus 2 over 6 minus 2. 5 minus 2 is 3. 6 minus 2 is 4. So my slope is 3/4. I could write that as a decimal if I want. So in this case, my equation for my line is y equals 3/4 is 0.75, 0.75 x plus 0.25, which was our b. So that comes right there. This goes right here. Okay, so not bad. We can use this now to make approximations of what our data should be. Let's look at another one. Again, we are going to figure out, I'm looking at this data and I think it's going to have a negative correlation. So I'm going to draw an oval around all of my data points. And when we do this, we can avoid data points that don't look like they match the pattern. We can just ignore those. Okay, so again, we're going to try to go about right in the middle of our data points. So I'm going to say the line goes from about, let's say right about here. Okay, so again, y equals mx plus b. Our b looks like it's about 7. Then we need to find our slope. Remember, when we're looking at the slope, we are not looking at the actual points. We're choosing points that are on our line. So I have this point, which is 6, 3. Ooh, that's a very nasty looking 3, 6, 3. And then I need another point that looks like it's really sort of there. So I'm going to choose this point right there, which is 3, 5. And I know that this is going to be a negative number. So again, our slope is m equals y2 minus y1 over x2 minus x1. So in this case, this is going to be m equals 5 minus 3 over 3 minus 6. 5 minus 3 is 2. 3 minus 6 is negative 3. So my slope is negative 2 over 3. My b was 7. So to write that equation, I'm just going to write y equals m, which is negative 2/3 times x plus 7. And that's it. Okay, and we could use that to actually find the data that we want for any of these. Okay, if you have any questions, see me in class.